Welcome to lecture series of Engineering Graphics and Design. Myself Ankur Patel, and today in this second session of projection of lines, we are going to discuss problems of projection of lines in which information regarding the true length of the lines are given. So before starting the problems of projection of lines, let us take the overview of projection of points. Plan of the point is denoted by small a, b, c, d, e up to z. Elevation of the line is denoted by a dash, b dash, c dash, d dash. Side view of the point is denoted by a double dash, b double dash, c double dash, d double dash. Now let us see the position of the point with reference to HP and VP. So the point is in first quadrant, that means it is above HP in front of VP. If the point is in second quadrant, that means the point is above HP behind of VP. If the point is given in the third quadrant, that means we can say that the point is below HP behind of VP. If the point is given in the fourth quadrant, we can say that the point is below HP in front of VP. Then after, a point is on HP in front of VP. Point is given on HP behind of VP. Point on VP above HP. Point on VP below HP, and last and the ninth position of the line is on HP and on VP. So on basis of these different positions given for projection of lines, we will get the plan and elevation of the point with reference to XY reference line. So let us see the conclusion of projection of points. So if the point is above HP, we will get the elevation of the point above the XY reference line. That means if the point is 20 mm above HP, the elevation of that point will be 20 mm above the XY reference line. If the point is below HP, the elevation of the point will be below the XY reference line. So if the point is given 15 mm below HP, we will get the elevation of that point 15 mm below the XY reference line. If the point is in front of VP, the plan of that point will be below the XY reference line. So if the point is 10 mm in front of VP, the plan of that point will be 10 mm below the XY reference line. If the point is given behind of VP, the plan of the point will be above the XY reference line. So for example, if the point is 25 mm behind VP, the plan of that point will be 25 mm above the XY reference line. Now if the point is given on VP, the plan of that point will be on XY reference line. If the point is given on HP, the elevation of that point will be on XY reference line. And if the point is given on HP and on VP both, then the plan and elevation of that point will be on the XY reference line. Now let us take the overview of the meanings of different terms shown in the diagram of projection of lines that we have discussed in our last lecture. So here the terms are TL, theta, alpha, phi, beta. So what are the meanings of these different terms? So TL is a true length of the line, and it is denoted by A dash B1 dash and A B1. F view or EL, that is the front view or elevation of the line, and it is denoted by A dash B dash. Then after TV or PL, that is the top view or plan of the line, and it is denoted by AB in the diagram of projection of lines. Then after EP, that are the end projectors of the line. So here is the EP. So what are end projectors? So this is the projector of A and this is the projector of B. And as we know that on the projector of A, we will get the elevation and plan of point A, and on the projector of B, we will get the plan and elevation of point B. And the perpendicular distance between the projector of A and projector of B, that are the end projectors of the line, are known as EP, which is end projector of line. Now theta. Theta is the angle of inclination of the line with the horizontal plane, and in the diagram it is the angle of A dash B1 dash. Here you can see that theta is the angle of A dash B1 dash, which is our true length. Now phi. Phi is the angle of inclination of the line with the vertical plane, and in the diagram it is shown by A B1 true length. So A B1 is our true length and it is shown by phi angle. So here we can see that the true length AB1 is inclined at an angle phi to the XY reference line, and this theta and phi are also known as the true inclination of the line. Then after alpha, alpha is the apparent angle made by front view of the line with the xy reference line, and we can say that alpha is the angle of a dash b dash. Here a dash b dash is our front view or elevation, and beta is the apparent angle made by top view of the line with xy. So here we can see that beta is the angle of AB, and AB is our top view or plan of the line. So this is our standard diagram of projection of lines, and these are the meanings of different terms used in the diagram of projection of lines. Now let's start with the first problem of projection of lines. So the given data is a line AB 80 mm long is inclined to HP by 30 degree and inclined to VP by 45 degree. The line is in the first quadrant with point A 15 mm above HP, 30 mm in front of VP. Draw the projection of the line AB. So the given data is line AB 80 mm long, that means the true length of the line is 80 mm. Line is inclined to a horizontal plane by 30 degree and vertical plane by 45 degree. So angle of inclination with the horizontal plane is theta, and angle of inclination of the vertical plane is phi. So theta is 30 degree and phi is 45 degree. And point A is 15 mm above HP and 30 mm in front of VP, and the line is in the first quadrant with point A 15 mm above HP and 30 mm in front of VP. And we have to draw the projection of the line by using this given information regarding the line. So right now the information regarding the true length of the line is given, so we will get the true length, and after drawing the true length we have to find the plan and elevation of the line by following the procedure. And the procedure to find the plan length and elevation length from true length, that we have already discussed in our last lecture, and if you want to see my last lecture, then the link is given in the description. So let's start. First of all, draw xy reference line. Now starting by indicating the point or by marking the point with reference to xy reference line. So point A is 15 mm above HP and 30 mm in front of VP. 15 mm above HP, that means from xy line or above the xy line 15 mm we will get the elevation of point A, and 30 mm in front of VP, that means in front of, we will get the plan 30 mm below the xy reference line. So this will be our locus of A dash, and this will be our locus of A. After marking A dash and B dash, now we have to draw a line, or we have to show a line having true length which is equal to 80 mm at theta angle and at phi angle. So and as we know that from A dash we can draw the theta angle, and we can show the true length at an angle theta. So draw a line at an angle of 30 degree from A dash and having length equal to TL. We can also draw this theta angle in the downward direction from xy reference line, but right now the line is in the first quadrant. So if the line is in the first quadrant, the point B will also remains in the first quadrant. So we will get the elevation of point B above the xy reference line and plan of point B below the xy reference line. So from the elevation we have to draw the line inclined at an angle theta in this direction, because we will get B dash above the xy reference line. So this will be our B1 dash. Now from A we have to draw a line inclined at an angle of 45 degree, which is our phi, angle of inclination of the line with the vertical plane in the downward direction, showing the true length which is 80 mm. So phi, this will be our B1. So we have drawn this line in this direction because we will get the plan of point B below the xy reference line, because the line is in the first quadrant. So this will be our locus of B1 dash and B dash, and this will be our locus of B1 and B. B1 dash and B dash, because we will get the B dash on this locus also, and we will get the plan of point B on this locus. Now how can we find the plan and elevation of this line? So if we want to find the plan, we have to draw the straight line from B1 dash to locus of A. Here we will get B2. So A B2 will be our plan length. Now we have to find the plan of point B also. So measure A B2 as an arc length and center as A. Draw an arc up to locus of B. Here we will get plan of point B, the intersection of this arc and this locus of B. So this will be our point B. Connect B to A. This will be our plan length or plan, and the angle of the plan length is beta. Now if you want to find the elevation of the line, we have to draw a straight line from B1 up to locus of A dash. So the intersection of this projector and this locus will be our B2 dash, and now A dash B2 dash will represent the elevation length, but we have to find out the elevation of point B. So if you want to find out the elevation of point B, that is B dash, measure the radius of A dash B2 dash on the rounder, take the center at A dash and give an arc on the locus of B dash. So here we will get B dash, connect A dash B dash will be our elevation length, and the angle of the elevation length is alpha. Now connect B dash B will be on the same vertical line, and this is the projector of B and this is our projector of A, and the perpendicular distance between projector of A and projector of B is known as the end projector of the line. So now let's move on to next example by having some same data but by changing the quadrant of point B. Here we have taken point B in the first quadrant and point A also in the first quadrant. Now let's see the next example with some different data. A line AB 80 mm long is inclined to HP by 45 degree, inclined to VP by 30 degree. The end A is 20 mm above HP and 15 mm in front of VP. Draw the projection of the line and also write the elevation length and plan length of the line. So after drawing the projection, we have to write the elevation length and plan length. So the given data is line AB 80 mm long, so the true length of the line is 80 mm. Line is inclined to HP by 45 degree, theta, that is 45 degree, which is the angle of inclination of the line with the horizontal plane, and inclined to BP by 30 degree. So the angle of inclination of the line with the vertical plane is phi, which is 30 degree. The end A is 20 mm above HP and 15 mm in front of VP. So it is given end A is 20 mm above HP and 15 mm in front of VP. So right now the point A is in the first quadrant, and we have to draw the projection of the line, and after finding the projection of the line, we have to write the elevation length and plan length of the line. Right now the quadrant of point B is not given, so we have to assume the quadrant of point B, and in first example the quadrant of point B is first quadrant, but right now we are going to assume the point B in the third quadrant. So assume the point B in the third quadrant, that means the B is below HP and behind VP. A is above HP in front of VP, that is first quadrant, and B is below HP behind VP, that is our third quadrant. So let's start. So first of all, draw XY reference line and mark this point, or mark the plan and elevation of point A. So A is 20 mm above HP, above, that means we will get the elevation of point A 20 mm above the XY reference line and 15 mm in front of VP. In front, that means plan, so we will get the plan of point A 15 mm below the XY reference line. So mark the elevation A dash and A, elevation 15 mm 20 mm above the XY line, plan 15 mm below the XY reference line. This will be the locus of A dash and locus of A. After marking A dash and A, now we have to draw true length at an angle theta and at an angle phi. So from A dash we have to draw, or we have to show theta angle. In our first example we have drawn the line from A dash at an angle theta in this direction, but right now we have to draw the line inclined at an angle of 45 degree from A dash at an angle theta in the downward direction, because our point B is in third quadrant. So if the point B is in third quadrant, it will be below HP behind VP, that means we will get the elevation of point B below the XY reference line and plan of point B above the XY reference line. So from the elevation we have to draw the line inclined at an angle of theta, which is 45 degree, showing the true line in the downward direction, because we will get the B dash below the XY reference line. So this will be our B1 dash. Now from A we have to draw a line inclined at an angle of phi, which is 30 degree, showing the true length in upward direction, because we will get the plan of point B above the XY reference line, because B is in the third quadrant. So this will be our B1, this will be the locus of B and B1. We will get the plan of point B on this locus. This will be our locus of B dash or B1 dash. We will get the elevation of point B somewhere over here. Now after drawing the true length at an angle theta and phi, we have to find out the plan length and elevation length of the line. So if we want to find out the plan length and elevation length of the line, we have to draw a straight line from B1 to locus of A dash. This will be our B2 dash, and A dash B2 dash will represent the elevation length of the line, but we have to find out the elevation of point B, which will be somewhere over here. So if we want to find out the elevation of point B, measure A dash B2 dash on the rounder, take center at A dash and give an arc up to locus of B dash. So intersection point of this arc and locus of B dash will gives us the elevation of point B, which is B dash. So connect B dash to A dash will be our elevation length, and the angle of elevation length is alpha. Now if you want to draw the or find the plan length of the line, we have to draw a straight line from B1 dash to locus of A. Here we will get B2, and AB2 will represent the plan length, but we have to find out the plan of point B. For that we have to rotate point B up to locus of B, and for that we have to measure AB2 as arc length, and by taking center at A and radius is equal to A to B2, give an arc up to locus of B. So here we will get B, which is the plan of point B. Connect B to A, which is our plan length of line AB, and the angle of the plan length is beta. And if we will connect B and B dash, this will be our end projector of B. Now after drawing the plan and elevation length of the line, we have to measure plan and elevation length of the line. So we will get the elevation length of the line, that is A dash B dash, equal to 69.28 mm, and plan length of the line, which is equal to AB, equal to 56.56 mm. And the distance between A dash A, that is the projector of A, and B dash B is known as the end projectors of the line. Now let's move on to next example by changing some data. A line AB 75 mm long has its end A 20 mm below HP, 25 mm behind VP. The end B is 50 mm below HP, 65 mm behind VP. Draw the projection of the line AB and find its inclination with HP and VP. So the given data is the true length of the line is 75 mm, and A is 20 mm below HP, 25 mm behind VP, and B is 50 mm below HP, 65 mm behind VP. So right now the point A and B both are in the third quadrant because both are below HP and behind VP. So right now the theta and phi, that is the angle of inclination of the line with HP and VP, are not given, but in place of theta and phi, locus of B is given. And we have to find the theta and phi. Theta is the angle of inclination of the line with the horizontal plane, and phi is the angle of inclination with the vertical plane. So let's start by drawing the XY reference line. And after drawing the XY reference line, first of all mark the plan and elevation of point A. So A is 20 mm below HP. So we will get the elevation of point A 20 mm below the XY reference line and 25 mm behind me. So we will get the plan of point A 25 mm above the XY reference line. So mark the plan and elevation of point A dash, which is 20 mm below the XY reference line, and A, which is plan 25 mm above the XY reference line. So this will be our plan, this will be our elevation, and this will be locus of A, locus of A dash. After drawing the plan or elevation of point A, now we have to draw the locus of point B. Right now we doesn't mark B dash and B directly because we doesn't have end projectors. So we can draw only the locus of B dash and B. So B is 50 mm below the XY reference line. So from the XY reference line, below the XY reference line, we will get the locus of B dash, and 65 mm behind. Behind that is plan. So we will get the plan or locus of the plan of point B 65 mm above the XY reference line. So this will be locus of B and B1. Now the remaining given data is 75 mm, which is our true length. So measure this true length on your rounder, or measure this true length as an arc length. Take center at A, give an arc on locus of B. Here we will get B1. Take center at A dash, give an arc on locus of B dash. We will get B1 dash. A dash B1, sorry, A B1 is our true length at an angle phi. A dash B1 dash is our true length at an angle theta. So now we get the theta and phi. So measure theta and phi by using the protractor. We will get theta 23 degree and phi 31.5 degree. After finding the theta and phi, we have to draw the projection of the line also. Projection means we have to find out the plan and elevation of the line. So if we want to find the plan of line AB, if we want to find out the plan of line AB, we have to draw a straight line from B1 dash up to locus of A. Here we will get B2, and A B2 will represent the plan length, but not plan. because we have the plan of point A but we doesn't have plan of point B. So if you want to find out the plan of point B, measure A, B2 as an arc length, center at A, give an arc up to locus of B. So here we will get point B, which is the plan of point B. Connect B to A, which is our plan length, and the angle of the plan length is beta. Now if you want to find out the elevation length, draw a straight line from B1 up to locus of A dash. Here we will get B2 dash. So A dash B2 dash will represent the elevation length, but not the elevation, because we have the elevation of A but we doesn't have the elevation of B. So now if you want to find out the elevation of point B, we have to measure A dash B2 dash as an arc length, center at A dash, give an arc up to locus of B dash. So here we will get the elevation of point B, intersection of this arc and locus of B dash will give us the B dash. So connect B dash A dash will be our elevation length, and the angle of elevation length is alpha. Now connect B dash to B. So this will be the projector of B, and this is the projector of A, and the perpendicular distance between projector of A and projector of B is known as the end projectors of the line. So take in the mind these end projectors, because in our next lecture we are going to practice the problems of projection lines in which end projectors of the lines are given. So this is it for today. Thank you for watching. See you in the next lecture.